A simple pendulum is an idealized model consisting of a point mass suspended by a weightless, inextensible string supported from a fixed frictionless support. Why bob is taken as point mass? To reduce the effect of air resistance or drag on bob and also making it closer to ideal pendulum. Why bob is taken as heavy? The bob is treated as a heavy because we assume the center of mass of the pendulum lies at the center of the bob. If the mass were distributed like in a rod, we would first need to calculate the center of mass, which would complicate the calculation of the time period. Taking the bob as a heavy point mass simplifies the analysis and allows accurate use of simple harmonic motion equations without considering rotation or uneven mass distribution. Why string is taken weightless? We take the string as weightless because the entire mass is concentrated in the bob. The string is assumed to be inextensible, meaning it doesn't stretch. This keeps the length constant, making the time period depend only on the fixed length, otherwise time period will change. Why frictionless support is taken? The support is considered frictionless and air resistance is ignored so that no energy is lost. Why does the weight have the same angle as the pendulum, making an angle theta from the vertical? From the figure, line OB is parallel to line PQ and line AB acts as a transversal. Therefore, angle theta is equal to theta dash. Because these are alternates angle. Also, line PQ intersects BC. So, angle theta dash is the vertically opposite angle of angle theta. Hence, angle theta dash is equal to theta. Working when the pendulum is displaced from its mean position through a small angle theta and released. Then it starts oscillating to and fro about the mean position. Components of weight. The weight of the bob can be resolved into two. Its rectangular components, mg cosine theta and mg sine theta. The other force in this case is the tension T in the string. Both T and mg cosine theta are equal and opposite to each other, so they cancel the effect of each other as shown in figure. So, T is equal to mg cosine theta. The only force responsible for the motion of the pendulum is mg sine theta, which is the unbalanced component of weight and acts perpendicular to the length of the pendulum. It brings the bob back toward its mean position, meaning it provides the restoring force to the bob. So the restoring force for the bob is F is equal to negative mg sine theta. Negative sign shows that force is directed towards the mean position, which means opposite to displacement of bob from its mean position as shown in figure. Also, we know that F is equal to ma. This is equations 2. Comparing above to equations 1 and 2, we get ma is equal to negative m g sine theta. A is equal to negative g sine theta. This is equation 3. From figure, sine theta is equal to AB over L. Since AB is equal to x and for small theta arc AB is equal to x, so equation 3 becomes A is equal to negative g multiplied by x over L. A is equal to negative g over L multiplied by x. This proves that the motion of the pendulum is simple harmonic motion because A is directly proportional to negative x, where g over L is constant.